Hello all, welcome to our project Hospital Mortality Prediction using PyCaret. So now in this project we'll be predicting different mortality rate, that is whether a person will live or not, with the help of different machine learning libraries and the automated machine learning library, that is the PyCaret. So now moving on, what is the motivation behind it? What is the need of this project? So basically what happens is, as it is written, the predictors of in-hospital mortality for intensive care units, the predictors which are there in the ICUs, admitted HF patients remain poorly characterized. So basically the predictors which are in the ICU models are poorly characterized. That means the accuracy is not that good. They provide not that good results. So we aim to deploy and validate a prediction model for all cause in hospital mortality among ICU HF patients. So what we'll be doing, basically we'll be making a model which will be doing this work for us, which it will be predicting the mortality rate among the ICU admitted patients in order to increase the quality or the accuracy. So now what we'll be doing, as I said, that we'll try to build a machine learning model with the help of different ML and AutoML techniques to predict whether a person will live or die after observing certain parameters. So now what happens is, in an ICU, as you all know, the condition is very uncertain. Anything can happen any minute. So the prediction can be very uncertain, but we'll try to build a model which will help us predict. It will not be certain because no one knows what happens in a human body, right? It is very unpredictable. But we'll try to predict on the base of previous data, okay, what happens when these conditions are followed. Then if all goes well, this can happen. So we have a data which have different attributes which will help us in predicting the outcome. We will try to predict based on the previous experience, previous data, what can be the possible outcomes. So now, as I said, we'll be using machine learning libraries and automated machine learning libraries. I hope you're all familiar with all the machine learning libraries. The new topic here is automated machine learning. So what is automated machine learning? Automated machine learning is basically a method or a technique in which it automizes the model development part. Basically, it automizes all the things which we do for building a model, tuning a model, checking accuracy, all of these things. These is a pretty important or useful thing. And then the automated ML library we'll be using in this project is PyCaret. So PyCaret is an open source low code machine learning library in Python, obviously, that allows you to go from preparing your data to deploying a model within minutes in your choice of notebook environment. So no matter what the notebook is, be it Jupyter, be it Google Colab or any other node environment, you can create your, you can use this PyCaret library, and it is a pretty popular library. Let's see why it has certain advantages. First is it increases productivity. So now, as I said that we don't have to write much amount of code, and all of these things get done with a single amount of code. So our productivity is increased, and it is always done in a better way. Okay, it will give you the best preparing model. In if you do manually, it can happen that some of the models you may miss, which could have performed better. But in the case of PyCaret, all of these things will be covered. Second is easy to use. As I said, in model development part using ML, we have to write ample amount of code and logic. But in this, we don't have to write anything. We just have to pass some amount of code to tune your model and to build your model, just a single amount of code, and we will get the work done. So that is easy to use and business ready because it provides us the option to deploy a model. Okay, if you are in a business, you have to deploy a model, you have to make your model in production. So this is a business ready module. So moving on to the timeline of the project, the very first we'll be doing some data analysis part. We'll be finding out different relations, observing our data visually. Then we'll be doing feature engineering or the data pre-processing part, making our data ready for our model development. Then we'll be building our model using machine learning techniques. Then we'll be building a model using automated machine learning, that is the PyCaret library. Here by mistake I have written Teapot library. We'll be using PyCaret library for PyCaret library for this project. So let's proceed to the building a notebook building sessions. Hello all, welcome to our project in hospital mortality prediction using machine learning libraries and PyCaret. So now, as discussed in the introduction section, I have already given you the context that why this model is necessary, why we are making this model, that in situ predictors are very have a less accuracy, and we have to make a model which will help this condition. So now in this we'll be using different machine learning models, then PyCaret AutoML library to predict the results in this notebook. So also we discuss the timeline that first we'll be doing the data analysis, then data pre-processing, then we'll be building models using ML libraries, then PyCaret library. So now the very first thing what you have to do, you have to import your libraries. Okay, you will be importing pandas as PD, NumPy, Seaborn, Matplotlib. Seaborn and Matplotlib basically for visualization, and pandas and NumPy for all the data processing and computing parts. So now as this is a Google Colab environment, you have to import your data first into your Google Drive. Then you have to mount your drive. You can mount your drive using this command. It can be obtained using clicking on this button. It will give you this command. You just have to click in this link and you have to sign into your account. Basically you have to give permission to the Google Colab so that it can read your data. So it will mount your drive. You just have to copy it and simply paste the authorization code here. That was the authorization code. It will give you authorization. Okay, sorry, it is giving. Let us try once more. Sign in. Let us copy it. We'll try it again. We'll go here. Maybe sometimes it can be a little challenging, or some of the things can happen. It is of no worries. We'll just copy the code again, then we'll paste it here. It will take around 10 to 15 seconds. Okay, as you said, it is mounted at content drive. So now what you'll see that your drive is mounted here and my drive, and all the data is here. In now my CSV file is mortality.csv. I'll go there and I'll see where is my file. This is my file. I'll just copy the path. I'll copy the path and I'll paste it here and read it using the pandas. Okay, I'll just read it using pandas. And now, so this is my file. So this is my whole file. Okay, so now this is how you read your data or import your data in a Colab environment. Now in the next section we'll be doing the data analysis part. In this we discussed how we can import your libraries and the data set. The next further section we'll be doing the data analysis, pre-processing and model building part. Hello all, welcome to the next section of this project, that is the data analysis part. In the previous section we had some introduction, and we saw that how we can import libraries and dataset in Google Colab. So now in this we now will be doing some data analysis part. We'll be visualizing our data, seeing different trends. So very first thing, let us describe our data. What this will do, this will give us a numerical analysis of all the numerical data present here. That is the, it will give us count, the what is the mean, standard deviation, minimum value, maximum value, percentile value of all the numerical variables or all the variables present. Let us see that if there are any null values or not. Okay, let us see if there are any null values or not. So 1 second. Yeah, now if we'll see that, okay, now if we'll see that there are around 250 null values in BMI, and all of the little null values in all of these things. Okay, so now what we'll do, let us first see the shape. Okay, this is the shape, and let us see the info. The shape is around 1177. That is 1177 rows, 51 columns. This is the info. Okay, this is telling us, okay, what are the data types of all our variables. So now the very first thing what we'll do, we'll handle the null values. Okay, for handling the null values, we'll first handle for the float variable. So as you can see, many of these are float variables only. So what we'll do, we'll import a library called S from simple imputer. What this will do, this will basically impute, or this will basically map the values in which we are providing. Can be imported using sklearn.impute. Then I'll define that, okay, as in simple imputer missing values is np.nan. A strategy is mean. That means it will impute all these values in by the mean of that data. Basically, to impute means to fill the values. Okay, impute basically to fill. So I'll just say float dot. I'll just get all my float columns. Then I'll say, okay, si dot fit df on my float columns. If you want to see what are your float columns. These are all my float columns in which this operation will be performed. So I have already performed this column fit. Then I'll say, okay, transform these columns with transform basically to transform all of these column, it will impute all these null values to their mean. Then I'll just simply drop all this. I'll just simply divide first my column for x and y to basically to remove my nan values from my dependent variable, right? Because my dependent variable also have some null values. So I'll just drop the outcome variable. Now I'll again use the same column. In that I'll replace my nan values with my most frequent. I'll replace my dependent column with my most frequent value. Okay. So now again I am doing the same thing. So now df my final, then I'll say that okay, there are no null values, my all my null values were my float values, and the next my dependent variable had null values. I removed it with the most frequent column. I have splitted my data into x and y. So now what we'll do, we'll just visualize some of our data. So now what we'll do, we'll just plot a pie chart, or in that we'll see that okay, what is the major outcome. Okay, though as you see that 86.5% people are alive, that is the outcome is this one. Then the death is around of 13.5, which is obviously death will be much more less than the living rate, right? So what I did, I simply used a command of pie chart. In that I gave the data outcome dot value counts. It automatically converted into different percentage. This is visualization techniques. This is the labels. Okay, so now again the next thing what I'm doing, I'm plotting an histogram between age and between age and the color outcome. Basically it will tell me that what is the outcome on the basis of the age. Okay, basically the outcome is one, that means the person is died. Okay, and now it is telling me that the age which is having 88 to 89, it is having the highest number of counts patients, and the death patient is also highest, 25 count is there. Okay, rest of all count is 12, 11, 14, 12, but the age group, obviously higher grade age group will have the highest count, and the maximum population is between the age group of 80 to 90, and in that the highest death count is around this one. And the next we'll be plotting this on the basis of the BMI. On the basis of the BMI, then we'll see that okay, how much BMI people is at the higher risk, or which is having the highest data. So as we'll see that BMI between 13 to 30 to 31 are the maximum population, and these are only having the highest death count. Obviously the BMI about 30 to 31 is considered little obese or greater than BMI, so that's why the count is very high, around 53. Okay, so now the next count is we'll be seeing with the SpO2, SpO2, that is the oxygen level percentage. So now as you already know that the oxygen level percentage, the normal oxygen level percentage is between 95 to 100. That is why more of our data is in here, and very less of the data is between this. Basically this is all our outliers, mostly of these are outliers only. As you can see, there are more of the outliers are present, because no person is alive and having a person SpO2 with less than 90%. That means they are in a very critical percentage. And as you can see, most of my data lies between 95 to 100 only, and death rate also lies between less than 100 also. But there are very less, only a count of two which is having 100% oxygen and they died, because that is a very unlikely option. They might have died with any other cause. The last we are plotting is with the heart rate. Now we'll see how our heart rate is distributed. So as you can see, our normal heart rate of a human being is around 65 to less than 100. Okay, that is why most of it are residing there. The more heart rate is, basically it means that it is the person is having a heart rate, it is having anxiety. But the majority of our data lies between the normal range only, and in that we see that the heart rate between till around 100 to 90 is having the maximum number of heart counts. Okay, so now basically it is normally distributed, right? It is not that some one particular heart rate is having maximum number of death rate, but it distributed normally. So but we can say that okay, maximum amount of our population is having a heart rate with 65 to below 100. Okay, so now the last thing what we'll be doing is, okay, this is the gender, that means basically the gender which is present. The last thing which we'll be plotting is the count plot. Okay, the count plot between the genders, that means which we did here. Okay, if it is one, then it is if it is one, then it is female. It is sorry, yes, it is one, then it is female, and it is, oh, I'm so sorry, I'm creating it right. If it is one, that means the person is deceased, and it is zero, that means the person is living. So as you can see, the majority of the more data is from the female side, and they are, and the death rate is almost similar. Okay, but you can see that the death rate in male is higher because the sample population is less, and the death rate is higher with the one outcome, okay, in male than in female. So we can see that female are living more. Then there are some correlation part and all of these things which we'll be doing in the next section, that means the next part of this video. So let's proceed to the next part. Hello all, welcome back to the next part of our data analysis section. So now previously we saw different graphs. We saw that okay, how different factors are affecting the our death rate or the mortality rate. Then we see that okay, which number of category, or which number of, if the male is greater or the female is greater, we saw that female number of people are more, male number of people are dying more than female. Then the next thing which we'll be doing, we'll be seeing different correlations between a variables, that is between numerical variables. I have taken all the numerical variables here. Then I have seen that okay, I have given a variable chord, then I'm saying give me the correlation between all of these. Then I'm just simply plotting a variable, plotting this variable in the form of a heat map. This is basically showing me how my variables are correlated. If it is negative, that means the variable is negatively correlated, and if it is positive, that means the variable is positively correlated. And I am easily getting all my correlation with the help of this color scheme. But we can see that none of these variables are much correlated from each other. Okay, the color scheme is very light, and very light is for below zero. So very few of these are variables are even correlated to 0.2. That means the highest, even the highest correlation is around 0.23. Okay, so now that means that these variables are not that much correlated to each other, but they are correlated to the outcome. Okay, so now let's see, the last thing which we'll be doing, we'll be plotting how our continuous variable are distributed. So first we'll be plotting the distribution plot of the age variable, how our age is distributed. Now as you'll see that the majority of our age is between 40 to 80, and I obviously above 80 no one will be there. Okay, the maximum life expectancy or average life expectancy is around 80 years. That's why the 80 years is at peak. Then the next variable is our EF. So now in that we'll be saying that okay, the maximum is around 40 to 60, or the basically the 60 column. Then we'll be seeing the RBC count. What is the RBC count for all the people? So as you can see, 2 to 5. Okay, you can see many, barely 5 to 2 to 4. The 4 is the maximum. The maximum RBC count is around 4. Then we'll be seeing the creatinine. What is the creatinine count? So now if you see that the creatinine count is also lies between 0 to 4 only. And then if we'll see the blood calcium part will also do the same thing, around 6 to 10. Basically these are some analysis part if you want to create a report, or to say that okay, what is the basic health conditions of my sample population. So you can use this data analysis. Basic data, what data analysis is for, to visualize your data, to make some insights. So we can do some insights from this. Okay, what is my distribution of sample population distribution, what is my distribution on the basis of my different properties like the blood calcium or BMI or creatinine, or my the RBC count, all of these things. Okay, so now this was my data analysis part. I am done with it. So now I have observed some crucial insights of my data, how my data is distributed, and some outcomes. So now the next thing which we'll be doing is we'll be doing the data pre-processing part. This is the DF final which I have done. Okay, this is my final data. In this we'll be doing some data pre-processing. So now the only thing which we have to do is we'll split our data, then we'll standardize our data. So now that we'll splitting our data into dependent and independent columns. X is my independent columns, all of these things except the outcome. I've dropped outcome for it, that is my dependent column. That is my dependent column outcome. Then I'll just simply standardize my data. Standardize my data, which means that it will standardize my data on some smaller scales. That means here you can see that it is around 98, 16, 155 unevenly distributed. Standard scaler will basically standardize or scale my data to a common platform between the smaller values to -1 to 1. Okay, So now as you can see, I've scaled my data. Now I'll just, now if I see that how is my scaled column, it has converted into an array. Okay, I'll again have to convert into a data frame. I'll say final x pd dot data frame. I'm taking my column, the same column for my x, the independent variables. Now if I'll see my final x, so this is my scaled final data and ready for my model development part. And if I'll see my y also, so this is my y. Yeah, I have not scaled this because there was no need. The last thing which I'll do, I'll just simply split my data. I'll split my data into train and test. If I want to see the shape, what is my shape? So this is my shape, 820, 350 is my train, 350 for 50 is my test data. I'll just simply drop the ID column which was of no use. I'll just drop my ID column. Rest of all I can use for my prediction. So now my data is ready for prediction. If I'll just simply see my final data, so this is my data. So now I just have to use the different models for my model building and prediction. So we'll be doing that in the next section along with using the automated machine learning library, that is the PyCaret. Hello all, welcome to the next section, that is the model development section using the machine learning techniques. So now in this section, in this model, I have chosen one single model, that is the XGBoost classifier model. Why classifier? Because this is obviously a classification technique which we have to classify or predict which person will be deceased or not. So the very first thing which I am doing is importing XGBoost. I hope you are all familiar with the XGBoost machine learning model. It is it is basically a boosting technique which uses different decision trees only to boost, and it has a certain criteria and an algorithm which you can see or understand in the XGBoost documentation how it's work. But here we are not discussing that. We are seeing how we can implement this. So I've imported XGBoost, plot tree, plot importance for basically the validation or seeing visualizing our results. Then we'll just define my model. I just train my model with the extra and wide range data. I've used random state 42. You can use any of the state. I have not hypertuned my model. I have not passed any of the characters. So the basic the default characters attributes are given in this XGBoost model. It has predicted my model with the X test. Then I'll use the predictions. Okay, these are my prediction in the form of an array. If it is 0, that means it is living. If it is 1, that means the person has deceased. Now if I want to validate, or if I see my models, okay, how my model is performed, if I want to see how my model is performed, I can simply use some classification report, accuracy score, or confusion matrix. So I'll just import all of these things. The first thing I'll be seeing is confusion matrix with my y-test and prediction. I hope you're all familiar with what confusion matrix is. Basically, confusion matrix are given me my false positive or true positive and true negatives. This is my false positive and false negative. My basic aim to see if my confusion matrix perform well is not is to basically reduce these values, false positive and false negative. True positive, I have to maximize my true positive and true negative. So my true positives are these, true positives are true negatives are these. That means there comes a higher in number. That means my model is predicted quite good. Then I can also see my classification report, which will all tell my what is my precision, recall, F1 score. As you can see, my precision is around 88%, recall 98%. F1 score is quite good, for 93% for the 0 and the 1 for 36%. Okay, so these are all a very good thing. That means my model is predicted rightly. So now the next thing I can do to see, okay, visually how my results are there, I can compare my models. I'll just concatenate, or I'll just join these two y-test and prediction values. I'll just convert them into a data frame. Then I'll see, okay, how are my results. Then you can see that, okay, it is corrected. This is my test data and this is my prediction data. As you can see, all of my models are exactly corrected, less than few. Okay, 0 to 0, 1 to 1. This 150 is wrongly predicted, that is 1, and predicted 0. So this is only a thing. Then I can also predict a ROC curve, accuracy curve, ROC or accuracy curve. That means the AUC, area under curve. I just have to import it, plot ROC curve, plot precision recall curve. I'll just plot my curve by giving the data. Okay, so this is my RC curve. As you can see, AUC is 0.84. That is the 84%. That means by 84, the higher the AUC, the greater the good the model has performed. That means my model is performed quite good, and I can, if I will hyper tune this model, I can take this model to greater accuracies. So the next thing which we'll be doing is we'll be seeing using the automated machine learning how I can use this model. So now in this section I only use the XGBoost model, the single model. I did not hypertune also. So I did this on purpose to make you realize how good this PyCaret library is, because in the next section we'll see that how we can use this PyCaret library and do all of these things, even hypertune our model, and we'll see that compare the results. Okay, what are the different results which we are obtaining by our conservative machine learning models and using the PyCaret library. Hello all, welcome to the final section of our project, that is the using automated machine learning. In the previous section we have done all the in data analysis part, pre-processing part, we ready our data for our model development, we developed our model using XGBoost, we saw the accuracy, we saw different accuracy curves. So now in this section we'll be using automated machine learning library, that is the PyCaret. I've already told you what PyCaret is. PyCaret is an open source low code machine learning library in Python that allows you to go from preparing your data to deploying your model. So now the very first thing what you have to do, you have to install PyCaret. So now if you are using your local environment, that is the Jupyter or your Google Colab environment, and you want to see the documentation, install it right in your notebook, you can use this command pip install PyCaret with the exclamation mark. You can directly install it. I have already installed it, that is why it is saying requirement already satisfied. Okay, so requirement already satisfied, that's why it is showing me all of these things. So now the next thing which we'll be doing is we'll reading our data again. We'll be reading our data again, so I don't have to do the pre-processing part in this, because I've already told you that PyCaret does the or can also do the pre-processing part and all of these things. Okay, that is why I'll just simply read my data from this. As you can see, I have already installed all of these libraries, like that is why it is saying finally found existing installation. That is why it is installing all of these libraries which it has installed. So now I'll just restart my runtime. You have to restart your runtime in order to allow Google Colab to read that library which you have installed. If you will not restart your runtime, it will not carry it will not do that operation. So now if I'll just import it, okay, I have to import pandas also. I'll just import it here only, because I restarted my runtime, right? So all of my libraries got unexecuted. So import pandas std. Then I'll just import it. I have imported my model. Then I'll imported my classification report, because all of these are my classification problems. So I have imported all of my libraries which are present under classification. These are my head. This is my data. Now all I have to do is I have to select my model. I have to select my model, that is I have to define my model. That I'll do by using this command model is equals to setup. I'll give my setup is a command which is used to define your model or to set up your model. Setup data, I'm giving df, and I'm giving target, what is my dependent variable, that is my outcome. I'll just simply execute it. Okay, I'll just simply execute it. It will ask me permission that all of these data it has correctly predicted that it is numeric and categorical data. Is it right or not? I'll just provide it with a Y. See how good it is. Okay, it is telling you what kind of data it is. Then I'll just simply, it is just simply taking it is just simply set up my model. It has told me, okay, what are the size of the data, what is my missing value, it is there are any missing value, that is the true, how many numerical features are there, how many categorical features are there, what are the things they are that are performed, transform train set, transform test set, 80 to 20% it has taken, then all the things which have performed, numeric computer is mean, all of these things, each and everything is there. Okay, what we did earlier, everything is there. Okay, so now all of these things, remove perfect collinearity, true, and all of these things are performed in data. That it is pretty amazing, right? It is pretty amazing how it is done. So now what I've just I did what I did is compared model. What I did, it took all the different models, it took all the different models, compare it on the basis of different accuracy, AUC, recall. Then I can see that okay, which model is performing my best. Now I can see that linear discriminant analysis model is performing my best. So I'll just use this model. All of these models are also there, ridge, rf, light, gbm, lr model, all of these things. Okay, so now if I want to see, I have to create my model. These are the id model, these are all the id which is respected to the certain model. I use I have previously created which now I am getting LDA model highest, then I'll just create that model LDA, then I'll use that model create model LDA. I am passing that ID. It will create that model for me. It is LDA. As you can see, it has created that model. Created that model along with all the accuracy for all the different things. The mean accuracy 89%, that is very good. We obtained the accuracy of around 85 in our XGBoost model. I'll just predict my model. X test is not defined. Okay, X test is not defined because I'm using the test data which I took from the previous model. I'll just define it once again. What I'll do, I'll just simply go here. What I have to do, I'll just go here and first I'll do all the imputing things which I have to do again. Okay, I don't want the visualization part, just want to split my data. So I'll just go here, data pre-processing. I'll just split my data into this. Now I have now I have my train data, final train data and test data. I can pass this text. I can could also do one thing. I could have splitted this data for in the using the PyCaret library also. But I am using the same data which I used in the same test data which I used for the previous model to compare. So I'll just use my test data ID not in index. Okay, ID not in index. Okay, because I dropped the ID column. I'll just have because the PyCaret model is trained this model with the ID column also. So I have to make sure I do not drop that ID column. So this is some of the problems you can arrive. So it is better that you split your data in that format only. You do not use the data for the previous column. So I'll just simply do that again. Plot the visualization columns. Plot the columns. Standardize our data again, train and test our data. Now my train and test data is there, then it should not give any problem. Now I'll just predict and my predictions are done, and these are my predictions. So these are my predictions. If I'll see right there, the score, the label is this is my prediction. So if the label is 0, that means the patient is out of danger. Label is 1, that means the patient is gonna die. So this is my score. That means it is validated this score with the test data. It is very high. That means the score is very high. That means it is high probability. That means this is a correctly predicted outcome. And this is, as you can see now, this was how you can use the PyCaret library, and you saw that how amazing this library is and how we use different features and different things easily in this, and how precisely it gave us the results. And we can also deploy this model. That's why they say this model is production ready or business ready, because it provides all the different outputs and all the different things, and we can deploy this model, make this model production ready. So this was an introduction, or this was a project made by PyCaret and the different machine learning library, that is the XGBoost. I have been providing this notebook and data to you. You can use this knowledge to make new models and use this and notebook to make this project of your own also. Thank you.